All right, so throughout this chapter, you've been learning about sequences. Chapter 1, we started with functions, and so here we want to talk about what's the difference between them. In this lesson, you will compare and contrast sequences with functions. By the end of the lesson, you'll be able to answer these questions. Is a sequence a function? What is the difference between a sequence, t of n, and the function, f of x, with the same equation? Consider the sequence -5, -1, 3, 7. Create multiple representations. All right, so anytime we're going to create a table, we're going to go 1, 2, 3, 4, 5. We want to go in order. It's easiest to see the growth pattern if we go in order. Also, your sequence is always going to start with 1, 2, 3, 4, and so on. So for example, if I graphed, let's see, 1 is -5, 2 is -1, 3 is 3, 4 is 7. In order to get the fifth one, I would need to figure out that this is +4, +4, +4, and that this is 11. If I graphed the first couple, so like 2, -1, and 3, 5, I think that's about right. 3, 3, sorry, 3, 3. Not this one. And then 4, 7. That would not be 1, 2, 3. 2, this is 2. So if I go over to 1, I've got to go down to -5. Those 4 points minus the one with the little X through it, those are the first 4 sequences, fifth one not fitting on this particular graph. So the explicit equation in this case would be a sequence. So we would say it is t of n equals, it was increasing by 4, so it would be 4n. And then if we had to go back one more space, we'd have to subtract 4, which would bring us back to -9, so -9. The recursive equation, that's going to need, first of all, one coordinate. In this case, we'll use t of 1, which is -5. In order to find the next term of the sequence, t of n plus 1, we would use the previous term, t of n, and the pattern was to add 4, add 4, add 4, so previous term plus 4. Is 400 a term of the sequence? So in order to figure that out, we would need to say, can we get 400 if we solve 4n minus 9? And don't forget, n has to be a whole positive number. So if we add 9 to both sides, 4n equals 409. And if I go to divide by 4, I know off the top of my head that is not going to be a whole positive number. So we would say no. And then I would justify it by saying I'm going to get 102.25 equals n. And I can say doesn't work because it's not a positive whole number. Create a table and a graph for the function 4x minus 9. Now, it looks an awful lot like the equation we had, but the function is going to go all the way back, or can go all the way back as far as -3, -2, -1, 0, 1, 2, 3, which is the most common series of points when we're going to graph a function. We always want to see what happens in the negatives, what happens at 0, and then what happens in the positives. So one of the big differences is that f of x includes all real numbers in the domain, right? All the x values can be anything, positive, negative, decimals, fractions, all of that. How can you see the differences? One is that this graph is going to be continuous. So a function is continuous where a sequence is discrete. So up here, when I graphed my sequence, I graphed dots. I did not connect them. My first dot was at +1. Notice I did not graph a dot for the y-intercept for the 0th term. When I graph this one, I am going to graph that -9. I'm also going to graph, let's see, 0 is -9. I have all the same other coordinates. And then I'm going to go back another 4, go back another 4, go back another 4. I can't fit them all on the graph, but the major difference that you're going to see is that at 1, -5, at 2, -1, and then at 3, 3, you're going to get let's see, 3, 3. I did it again, that same point. I went too high again. This one I'm going to graph, and because it's a function, I'm going to connect the dots and do a line to show that it's continuous. So major differences there. Connecting the dots because it's continuous, going all the way back through the y-axis with a straight line. For the function f of x equals 4x minus 9, is it possible to have an output of 400? Sure. We already proved that that was possible up here. We got that x equaled 102.25, which is perfectly fine. The domain, oops, sorry, can't see that probably. Domain includes all real numbers, where this one was a no because we couldn't have that decimal or fraction as an input. Inputs had to be positive whole numbers. All right, so let us consider the difference between t of n equals 2 times 3 to the n versus f of x equals 2 times 3 to the x. Is f of x equals 2 times 3 to the x a function? Is t of n equals 2 times 3 to the n a function? We would say yes to both. They are both functions because they both have a single input, a single output for each input. If I plug in 6, I'm going to get the same single output each time. If I plug in -3, even though a sequence wouldn't have a negative third, I would get the same output each time. So a single output for each input. Also, we could say they both pass the vertical line test. If you think to the graphs that we just drew, one is a sequence, one is a function, both pass the vertical line test. Is it possible for t of n to equal 1400? If we wanted to solve, we could, probably the easiest way to do this would be to plug in values like t of 5. So if I did 2 times 3 to the 5th, I would get 486. If I did 2 times 3 to the 6th, I would get 1,458. And that's on either side of 1400. So no, we're not going to get exactly 1400 as an output because we get numbers on either side. Whereas if we wanted to get an answer for the function, we would say yes. Again, the domain is all real numbers. You'd say, 1400 equals 2 times 3 to the x. You would divide both sides by 2. 700 equals 3 to the x. And you'd have to use a calculator to do it. I'm actually not sure what it is off the top of my head. I didn't do this one ahead of time. But 3 to some power will give you 700, or very closely, approximately 700. How are the functions and sequences similar? Same operation and numbers. How are they different? T of n is discrete, right? You only have the points. F of x is continuous. Is a sequence a function? Yes, because of the one output for each input. It just happens to have a different domain. So one output for each input, and the domain DOMAIN, not sure what I was spelling the first time around. Domain is positive integers. Write the first 5 terms of the sequence. In order to do that, you simply plug in 1. So 2/3 times 1 and then take away 1 is -1/3. Do it again. 2/3 times 2 minus 1 is +1/3. Do it again. 2/3 times 3 is 1 whole. 2/3 times 4 take away 1 is 5/3. 2/3 times 5 take away 1 is 7/3, and you would keep going. First 3 terms. Make sure you're paying attention when you're being asked on, say, a test or a quiz. This one's only looking for the first 3. So 1/4 times -8 to the first is going to be -2. 1/4 times -8 to the second, that's going to give you a positive number because you're squaring. It's 16. This one's going to be 1/4 times -8 to the third because you're cubing. You're going to keep the negative and so on. So when your exponent is your variable, it'll flip-flop. Write an equation for the sequence -4, 4, -4, 4 using A of n notation. This is just another way of doing sequence notation. Means the same thing. You can see it's actually down in the bottom of the page under methods and meanings. The change here is times -1 times -1 times -1. So A sub n equals 4 times -1 to the nth. Your 0th term is 4. It would have been the one before this. Times -1 is your multiplier. On this one, you're doing plus 6 plus 6 plus 6. So A of n would be 6n. Adding 6 repeatedly would be 6n. And if you do the one before it, it would be plus 1. So this is kind of a wrap up. Not a lot new, clarifying some slight differences between sequences and functions. Still going over explicit and recursive sequences, and just throwing in that one other notation there at the end for sequence notation. But not too bad. Don't forget to review that methods and meanings at the bottom of the page as well. See you in class.